Hello guys, today I want to share an example from the help documentation. It is about elastic indentation of the foam material. As we can see, the result showed the top part is a rigid ball and the bottom is a rigid plane. So the big one is a foam cushion. We create the model as eccentric model. So through the sweep method, we can make them to 3D visualization. Okay, so let me show you the result. As the ball is pushed down to the cushion has a bigger deformation, and as we can see, there are two steps in this analysis. The first is to push down, and the second one is to pull it up. So because it is elastic, so as the ball is pulled up, the deformation diminished. Then let me take you through this creation process of this model. First, we have three parts in this model. The first is impactor and the ball, and second is the cushion, foam cushion, and the third is a rigid, analytic rigid plane. It represents the floor. As we can see, in every rigid part, there is a reference point to character the rigid. So, as the material property, we only need the material property of the former cushion. So, the former cushion has a hyperfoam property, and we can define it from elastic hyperfoam, and then we can use the test data as the definition method. For foam material, we need the relationship of stress, strain, and the strain energy. So we define the strain energy potential what to 2, and through the subportion, we can define the sample shear test data in this one, and unit action test data, this one. As we can see, the data is got from material experiment. In hyperfoam material, the stress and the strain are nominal stress and nominal strain, not true stress and true strain. As we can see, this is from a compression test, and this shear test data we need to define the nominal stress, strain, and transverse stress. And in addition, we define the viscoelastic material property. This one can be defined from elasticity and viscoelastic. In viscoelastic, we can define in time domain and the frequency domain. In this example, we use the time domain, and the time option we choose the relaxation test data. There are three methods. In the test data, we just have the shear test data, so we put in these parameters as input. This is a classical property parameters of hyperfoam material. As we notice, in the part, they are all asymmetric parts, so it seems like 2D, two-dimension parts, and in property, we need to create a solid, homogeneous section property. The first one, and the material is what we just created. After this, we need to assign the section property to the part. Then its color gets gray. Then we get into the assembly module. In this module, we put the parts in the correct position. As we can see, this is the floor, this is the hyperfoam cushion, and this one is impact ball. After this, we created two steps. The first one is push down, and the second is pulled up. In each step, we get the non-GM on, and then we modify the increment size, the initial increment size, and maximum increment size, and maximum number of increments. The second is the same. This is helpful for the convergence. So in the history output, we need to gauge the displacement of the ball and the force of the rigid floor. So we have created two sets. As we can see, we create lots of sets here, and this one is representing the impactor. We need to output the react force in the y direction, and we need to get the contact area of the ball and the cushion, and the displacement of the cushion. The domain is the set we created for the impactor. So in the interaction module, we need to create the contact and contact property. As we can see here, we have a friction coefficient of 0.8, and we created two contacts. The first one is cushion and the rigid floor. Between these two, we use the rough property. The friction coefficient is 0.8. It presents the cushion to move, and between the impactor and the cushion, we get the default contact property, and the discretization method we use node to surface. After we created the contact, we can get the output of the contact area. In the domain, we choose interaction. There we have two contacts to choose, and we choose the ball and the cushion. It's into two. Here we need to get the contact area. Because the cushion got big deformation, the contact area could change a lot. So after the interaction module, we need to create the load and boundary. In this example, we just give some boundary and displacement. Here we fixed the rigid floor, and then we get this left nose as asymmetric. So we fix the U1. Then we get the ball, fix the rotation freedom, degree freedom, and fix the U1. So the ball just can move up and down. In the step 1, we need to push down the ball by 215. And in the second step, we deactivate it and created a new displacement. In this step, we need the ball to move to the origin position, so the displacement of U2 is 0. So in these two steps, the ball be first down and back. Here we just set the model. Then we need to get the mesh. In this model, we just need to mesh the Hyperfoam cushion. As we can see, the element size is not fixed. So from left to right, the element gets bigger. And the element type is CIX4. After all of this, we can create a job and submit it. Then after an hour or so, we can get the results. This is the contour plot of the stress, and we can see the movie. It looks really as reality. So in the history output, we get 3 curves. The force, the displacement, and contact area. As we can see, in the last increment of first step, the contact area is largest. And then as the ball pull up, the contact area decreased to 0. And the force as the ball pushes down, the force is get bigger and then decrease to 0. This is the rule. So this is a simple contact example. If you want to get this IMP file or CAE file, you can contact me by email. Thank you for watching, and if you have interest in ABAQUS CAE, just subscribe my channel. Thank you.